Hey, what's up, guys? How's it going? In this video, I'm going to walk through this Leetcode problem, converting an integer to English words. So, what it's asking is to, let's say, if we are given a number, looks like this. So, 1, 2, 3, and we have to convert to 123 as a string, which is an English word we're defining here. And last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So we have to convert to 1,234, etc. And this question was asked by Amazon, Facebook, Microsoft, Adobe, LinkedIn, Google, Apple, Barclays, Walmart, and Square. And this question was not that great, but it was asked by many different companies because you can see how many people dislike it. And let's walk through a little animation to see how we can solve this. So let's say we are given these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and we have to break it in pieces, right? So we break it every other 3 digits. So as you can see, 0, 9, 8, 7, 5, 6, 5, break in the different sections, and then we deal with them separately. So as we can see, the first number correspond to the billion, and 234 million, 567,890. Okay, and then yeah, that's exactly what I just mentioned. And then at the end, we convert to a string. So as you can see, we can solve it by recursion, because as you can see, 234, 567, and 890. And the number between is just break it up to billion, million, and thousand. So let's walk through the code together to see how it works. So first thing first, we have a edge case where if the number is 0, we just return the 0 as a string. And then we need some helper array. So for example, from 1 to 19, so we have 1, 2, 3, 4, 5, 6, 7, all the way to 19, and as a list. Also, we have the tens, so 20, 30, 40, all the way to 90 as a list as well. And as we saw earlier, so the breakup, you can see the threshold, right? So we have a billion, million, thousand, and hundred. As you can see, so billion is 10 to the power of 9, million 10 to the power of 6, and thousand 10 to the power of 3, 100 10 to the power of 2. As I mentioned, we need to use a recursion method to solve this problem. So I have a helper function named recursor, which takes a number as a parameter. So if the given number is 0, which is not the same as this 0, basically this is a remainder as 0, and we return a string. I will walk through some of the examples below, and you will understand why we need to do that. And if the number is greater than 0 and less than or equal to 19, and then we just look up to this list that we just created. And for example, if we are getting a number 19, and then we just direct look up to the 18th, which is a 19th spot, the 18th index to this 219 list. And if the number is greater than 19 and less than or equal to 99, and we have to deal with by 2 sections. One is the 10th, right? Another one is the then all the way to 19. So for example, if the number is 99, and then we take the floor duration, and then minus 2 because we look at the index, and then plus the empty space in between, and then the rest we can store it back to the recursor and then deal with it again, because that's the number form. This is the remainder, right? Which is the modular. And also we have to deal with the edge case where if the number is only 20, so 20 of modular of 10 will be 0. Okay, and then we have to throw back to 0, return an empty string. However, we concatenate a space in between. That's why if we throw 20, so that will be 20 plus some empty space in between. It will be looks like this. and there's an empty space in between, which is exactly this. And to deal with that, we have to put a R strip to strip off the empty space that comes after the word. Okay, and the rest is pretty trivial. I think that's the reason why there's so many people don't like this problem, because it's uh, you don't learn a ton other than just recursively call, but you have to deal with all of edge cases. I think this problem is kind of interesting, but yeah, a lot of repetitive work going on. I mean, we can find a way to organize the code a little bit, but I want to present it more intuitive way, so it's easy to be understood. That's why I laid it all out. But we can, as you can see, if you can be creative to bundle these cases to use a more compact form, and yeah, you can browse the solution. People do that in the discussion forum. But I just want to lay it all out. It's more straightforward and more intuitive. And the save space, the time complexity is not going to save a ton by doing the more compact form. And anyway, let's move on to the second case, where if the number is greater than 100 and less than or equal to 999, and we do a floor duration of 100, so we extract. Let's say if the number is 101 or 100, we extract the number at the beginning, right? So we recursively call the number at 1, and then plus or concatenate the string of 100, right? And then we recursively call the rest. Okay, and for the same reason, we have to do the R strip to strip off all the potential empty space at the end, where if we are getting a number like 100, 200, 300, 400, all the way to 900, and in which case the modulo of 100 is 0 in that case. That's why we have to strip off the empty space comes at the end. And the other two cases pretty trivial. Just a for example, for this case is 999. If we come back to this table, which is 10 to the power of 3 minus 1, and then million will be 10 to the power of 6 minus 1, and then a billion will be 10 to the power. Sorry, for the thousands case, we have to do the maximum will be 999,000 and 999. So it will be a million minus 1. So it's 10 to the power of 6 minus 1. For the millions case, will be 10 to the power of 9 minus 1, which is at the maximum boundary, where if a 999 million, 999,000, and 999. And for the rest will becomes the billion. And then we deal with the we do the floor duration according to this table, right? So we floor duration of 1,000, floor duration of a million, and floor duration of a billion, and then separately do with the recursion. So essentially, what is going on is we have a string looks like this. We deal with the first number and then do with the rest, and then throw it back to the recursion and deal with the first 3 digits again and deal with the rest, recursively calling this function. So let's run it. Yeah, it looks pretty efficient. And for time complexity is a big O n. Basically, we just recursively dissect the number to different sections. So pretty straightforward. Space complexity BO1. That's a reason right here. So this is so much for my solution. I hope this is helpful. If it is, please like and subscribe. That will be a huge support. And I will see you in the next video. Thank you.